Good morning, everyone. So today we are starting with chapter 9 of the statics course. The title of chapter 9 is Center of Gravity and Centroid. All right, so this is the first lecture of chapter 9. So let's talk about center of gravity and centroid. What is a center of gravity? You must have studied this in your physics course, right? So center of gravity is where the weight of the body acts, right? And what is a centroid? Centroid, we can just say this is the geometric center of a rigid body, right? Okay, so let's move forward and let's see what do we have in this chapter. Okay, so let's first talk about the center of gravity. We commonly use this term CG for center of gravity. We also show it with a big G, capital G, right? So this is a point where the weight of the body acts, right? We know that weight is due to gravity, right? So whenever there's a body, there's a structure in a gravitational field, like in our world, then it has some weight, right? So the weight acts due to gravitational field. Now, the weight of the body acts at a point. Now, that point is called center of gravity, right? Okay. So, if we say that a body is composed of an infinite number of particles, and if the body is located within a gravitational field, then each of these particles will have a weight dW. Okay, so if you look at this figure here, so let's say that this is a rigid body, this shown in this blue color, this is a rigid body. Okay, now it is composed of infinite number of particles, so many particles, right? So let's say that this is a particle. This is one particle out of those infinite number of particles, right? So now, as the rigid body has some weight, let's say a weight W, then this particle also has some weight. Let's say a weight of dW. So every particle has a weight of dW, right? So now, if you integrate dW, then you get the weight of the whole rigid body. Okay, so this is one assumption that every particle has a weight of dW. Okay, now if you look at this figure here, what does this show? The same rigid body. This is the rigid body which is shown in the gravitational field. Now this is point G, right? This is point G. So this is the center of gravity of this whole body, right? And this weight W, this guy is acting at this point big G, right? So that's the point where the weight of this rigid body is acting. And this point is called center of gravity. Okay, so center of gravity is a point often shown as capital G, which locates the resultant weight of a system of particles or a solid body. Okay, so we already discussed about this. Now let's talk about centroid. Okay, so centroid is a point defining the geometric center of an object. Okay, so first we talked about center of gravity. Now we are talking about centroid. Okay, so if you take this example, this is a rectangular area, right? Rectangular area with a length, with a width of B and height of H. Okay, so this is your B and this is the height H. Okay, now if you look at this rectangular area, so it has two axes of symmetry, right? This is an axis of symmetry, this guy along x-axis, and along y-axis it also has an axis of symmetry. Okay, so it has two axes of symmetry. Now you must have learned about the axis of symmetry in your physics course, right? Axis of symmetry divides the cross section into two equal parts. So if you talk about this line this line, this is dividing this cross-section into two parts, two equal parts, right? And similarly, this line, the vertical line, also divides this cross-section, this rectangular cross-section into two equal parts, right? So it has two axes of symmetry, okay? So once a shape has two axes of symmetry, then the centroid of that shape lies at the intersection of those two axes of symmetry, right? So in this case, this is the centroid. Okay, so this is your big C. So this is the centroid, and that's how you find the centroid, where you have two axes of symmetry. Okay, now some other things, some other points about the centroid. The centroid coincides with the center of gravity only if the material of the body is homogeneous, which means that density is constant throughout the body. Okay, so this is another important point, that if the material of the body is homogeneous, which means that density is constant throughout the body, then centroid and center of gravity will be at the same point, right? Okay, so this is another point. Okay, now let's look at this figure. This figure, which is a triangular area, okay, with a width of B and height of H. Now we know what is the area of this triangle, 1/2 times B times H, okay? And this is the centroid right here. This is the geometric center, okay? Now, we cannot have the axis of symmetry in a triangular, this kind of shape, right? So we know that the axis of symmetry is 1/3 of H from the bottom. Okay, so that we know. All right. Okay, so that's about the triangular area. Now let's talk about this cylinder. If we have a cylinder like this, okay, with the height of H and volume of course we know that it's pi r square times H, okay, and we have X, Y, Z axis. All right, so now where is the center of gravity? It's right in the center, right? So here's the center of gravity or centroid of this cylinder, okay, at height h/2 from the bottom and on the z-axis. Okay, all right, so some more about the centroid. If an object has an axis of symmetry, then the centroid of the object lies on that axis. Okay, so if you remember, we talked about this shape, that it has two axes of symmetry, and at the intersection of these two axes of symmetry we have the centroid, right? So this final point, what it means, that if the object has one axis of symmetry, right, then the centroid will lie on that axis, but we will not be knowing the location, right? So we'll have to find out the location, but it will be on that axis. Okay, all right, so this was about the centroid. Now, how to find out the location of center of gravity? Let's come back to center of gravity. We just did some introduction about the center of gravity and the centroid. So now let's talk about how to find the center of gravity of an object. Okay, so the location of center of gravity measured from an axis is determined by equating the moment of W about that axis to the sum of the moments of weights of the particles about this same axis. Okay, so make some sense. Now let's look at this again, the top figure. So we have a rigid body shown in blue color, and it consists of infinite number of particles, as we discussed before, and every particle has a weight of dW, right? And now one more thing, because now we are going for the location. So let's take the location of this this particle, right, which the particle which has a weight of dW. Okay, So what is the location on X, Y, Z axis? So it has a location of X bar, Y bar, and Z bar, right, from the origin. Okay, so now we know the location of this particle. Okay, now if you look at this figure, so now we are talking about the whole body, whole object, whole rigid body, right, which has a center of gravity right here. This is your big G. Okay, so now the location of this center of gravity of this object is X bar, Y bar, and Z bar, right? So in the top figure, the X bar, Y bar, Z bar is for the particle, and in the bottom figure, the X bar, Y bar, Z bar is for the whole body, for the center of gravity of the whole body, right? So now let's come back to the theory. So we already talked about this. Now, if dW is located at point X bar, Y bar, Z bar, as we saw in this figure, then you can write this, right? X bar W equals integral of X bar dW. Right? Now this, the first X bar is for the whole object, for the whole body, and the second X bar, which is on the right side inside the integral, is for that particle. Right? So by following this, we can write this equation, right? So this is for the x-axis or the x-coordinate of the center of gravity, and similarly we can write this for the y-axis or y-coordinate, and this is for the z-coordinate, right? So y bar times w equals integral of y bar of the particle times dw, and similarly z bar times w equals integral of z bar of the particle times dw. Okay, so now from here we can find the location of the centroid of the whole body, right? So we can find this x bar, y bar, and z bar of the whole body, whole object, right? So x bar will be integral of x bar dw divided by integral of dw. Okay, and similarly y bar is integral of y bar times dw and divided by integral of dw. Okay, so just rearranging these three equations, we get these three equations, and from here we can find out x bar, y bar, z bar, which will be the center of gravity coordinates of the whole object. Okay, so that's how we find the center of gravity. Okay, all right, now let's talk about centroid and center of mass or center of volume, all those things. Okay, now we already saw this equation here, right? This guy. So we already have these formulas, these equations for x bar, y bar, z bar, right? In case of center of gravity. Okay, so now we can use these three equations, and we can replace w with the mass in these equations, and we can find out the coordinates of center of mass, right? So in place of dw, we can use dm, right? So we can replace m with w, and then we will find the center of mass. Okay. So these are the formulas or equations for center of mass, right? Okay. And similarly, the coordinates of the centroid of volume, area, or length can be obtained by replacing W by V, A, or L, volume, area, or length, right? So we can find those kind of centroids also. Okay. So that was all about the theory portion. Now we have a handout for today's class, and let's go over to the handout and let's solve some problems. Okay, so this is problem 1 on your handout. We have this area and we need to find the centroid location. All right, so we need to find the centroid of this shape, right? So we have this curve, y equals x cubed is the function for this curve, and it's 1 meter along x-axis and 1 meter along y-axis. So it's sort of a triangle, but it's not really is a triangle because we have this function for this curve, right? So we cannot find with the general triangle formulas, right? So we need to find the centroid of the shape. Okay, so let's see how we go about it. How we go about finding out this centroid of the shape. Okay, so here we have the same picture, same figure drawn here. The curve, the equation of the curve is y equals x cubed. Now let's go step by step and do this problem. Okay, so first step is taking a vertical rectangular strip of area dA. Okay, so which is being done here. Now in this figure you can see we have x-axis, y-axis, okay, and we have the same triangular area. Okay, now we'll take this vertical rectangular strip. Okay, so let's take this vertical rectangular strip, this guy, right? So let's take this rectangular vertical strip. Okay, so once we have this rectangular vertical strip, then let's define a few things. Okay, so the length of this vertical strip is dx. Okay, this guy. So now this is dx, and this is the centroid of this strip. Okay, so and this is the centroid. Now we can find x bar and y bar of this strip. So let's say that this is x bar of the strip, right? And this is y bar of the strip. Okay, so the location of the centroid of this strip is at a distance of x bar from the origin and y bar from the origin. Okay, along x and y axis. All right, so we know this. Now the height of this strip is y, and that's about it, right? And we know that y bar is equals to y by 2, right? Because the centroid has to be in the center. So that's what we have. Okay, and we assume that the top of this, the top surface of this strip is flat. So we have a rectangular vertical strip. Okay, because it's really small. All right, so now if you come back here, okay, now what is the area? What is the area of the strip? So this is the step 2 after we take this rectangular vertical strip in the step 1. Now we are at step 2. So in step 2 we need to find the area of this strip. So let's call it dA, and dA equals how much? Y times dx, right? If you look at the figure which we have drawn of this vertical strip, so the area is base times height, which is dx times y, or y times dx. Okay, but we already know that y equals x cubed, right? So let's put that in this area equation, and we can find this area in terms of x cubed times dx. Okay, so area dA equals x cubed times dx. Okay, now from this figure we can also say that x bar equals x. So this guy, x bar, let's say this equals x, and y bar equals y by 2. So x bar equals x, y bar equals y by 2, and just put y equals x cubed, so y bar equals x cubed by 2. Okay, so let's take everything in terms of x. Right, the value of x bar and y bar both in terms of x. Okay, now Now we can just apply the equations which we already learned about during this the earlier part of the lecture, how to find out x bar and y bar of the whole area. Okay, so let's do that. How to find, this is your step 3, find x bar of the area, right? So x bar equals integral of x bar of the particle times dA divided by integral of dA, right? So this is the same equation which we learned earlier, and instead of dW, we have replaced it with dA, right? Because we are talking about the centroid of the area, okay, not the center of gravity. All right, so now we can apply this equation, just put in the values of x bar of the particle times dA, right? So what is x bar of the particle, which equals x, right? So just put an x here, this guy, and what is your dA? We already know here, right? dA equals x cubed times dx, okay? So just put in the value of dA here, x cubed times dx. All right, so you just put x cubed times dx, and in the denominator you only have integral of dA, so integral of x cubed times dx. Okay, now what are the limits on these integrals? So we have 0 to 1 meters, so we will have the limits of 0 to 1. So 0 to 1 here, 0 to 1 here. All right, so this will be the limits. Now we can just analyze these integrals and find out what is the value of x bar. Okay, so if you just take the integrals, first just simplify, so it will be x to the 4 times dx and x cubed times dx. Now if you just do the integrals, you'll get this guy 1 by 5 times x to the 5 and 1 by 4 times x to the 4. Again, limit 0 to 1 for both the numbers, right? So if you just solve that, you'll get this 1 by 5 divided by 1 by 4 equals 0.8 meters. Okay, so that's how we found this x bar, which is 0.8 meters. Okay, so now if you come back here, now your x bar is 0.8 meters, so it's somewhere here, right? Somewhere here. This is 0.8, let's say. All right, so now we need y bar. So we need y bar to find out the exact location of the centroid of this area. So as we did for x bar, just do the same for y bar. Now this is how we do it for y bar. This is y bar. This is your equation, integral of y bar times dA, and mind that this y bar is for the particle, divided by integral of dA, right? So this is the equation which we can apply to find out this y bar. Okay, so just put in the values. Y bar, we know what is y bar, right? So y bar is x cubed by 2, and dA is x cubed times dx, and denominator we only have the integral of dA, so x cubed times dx. Okay, all right, so if you did that, now just simplify this a little, so we get x to the 6 by 2 and x cubed times dx in the denominator. Okay, now after this we just apply the integrals and we get this 1 by 14 times x to the 7, and here 1 by 4 times x to the 4, and limit is the same limit, 0 to 1, right? Okay, so if you just apply the limits, you'll get this guy 1 by 14 divided by 1 by 4. So you get 0.286 meters for y bar. So this is your y bar, 0.286 meters, and x bar we already found out is 0.8 meters. Okay, so now if you come back here, x bar was 0.8 meters, right? So this was your x bar. Okay, y bar is 0.286 meters, right? So let's say somewhere here, right? So this is your y bar, 0.28 meters. Okay, so now this is your centroid of this area. Okay, so now after you are done with finding out the values of x bar and y bar of the area, then you can just locate that point, and visually you can see that either you are correct or maybe there's some mistake, right? Because visually you can say that, okay, this is the centroid or is this not the centroid. So by looking at the picture, you can say, okay, this looks like the centroid. But if you get a centroid somewhere here, right? So that's not correct, right? Because visually we can say that that is not the centroid. Centroid has to be in the center, because this is the geometric center of the area or of the body, or maybe of the volume, right? Okay, so now let's go to problem 2. Okay, so this is problem 2. Again, we need to locate the centroid of the area. This is the area which is given. We have x-axis, we have y-axis, and we have this kind of shape, this kind of area. Okay, this is 2 meters, the height is 1 meter, and this is the equation for this curve. Y equals 1 minus 1 by 4 times x squared. Okay, now let's see how do we go about this problem, problem 2. Okay, so this is the figure drawn for this problem 2. Now, again, we'll go step by step. So step 1, we know that we need to take some kind of strip, okay, vertical strip or horizontal strip. So today we are just taking vertical strips, but next time or next lecture, we'll do some problems with the horizontal strip, right? Because either you take vertical strip or horizontal strip, you should get the same answers, right? Okay, so just take a vertical strip of width dx, right? Same as we did before. So we take this vertical strip, right? This guy with the centroid somewhere here, right? And the width of dx. Okay. Now this is the centroid of this strip. Okay, so let's call it C. And now let's take the location of the C, centroid of the strip. Okay, so which is x bar. Let's take x bar equals x, and y bar equals y by 2. Okay. All right. So I think that's about it. Now let's talk about the strip area. Okay. What is the strip area? So strip area, which is dA equals y times dx, right? Width times height. So dx times y or y times dx. Okay. Just put in the value of y, we already know what is y, right? We have this function, y equals 1 minus 1 by 4 times x squared. Okay, so just put in that value here. So this times dx is your area. And we already know what is y bar, is y by 2, right? So just put in the value of y, because again, we have this vertical strip, so we need everything in terms of x, okay? So y bar is 1/2 of 1 minus 1 by 4 times x squared, and x bar equals x. All right, so okay, so now we have all the values done. We got the strip area, we got y bar, we got x bar. Okay, now we can go ahead and apply the equations for the centroid, and we can find out what are the centroids, x bar and y bar. Okay, now before we go over to the equations, now if you again have a look at the given figure, right? So the area is symmetric, right? What does that mean? What does that mean that area is symmetric? Area symmetric means that this is the axis of symmetry, right? This is the vertical axis of symmetry. Oops, okay. So this is your axis of symmetry, okay? Axis of symmetry. So this is your axis of symmetry, and which divides the whole area into two equal parts, right? But we do not have a horizontal axis of symmetry, okay? So we only have vertical axis of symmetry, okay? So since we have vertical axis of symmetry, so we know that the centroid of this area lies on this axis somewhere, right? But it will be on this axis, okay? So maybe it's here, maybe it's here, maybe it's here. By just visualizing the area, we'll say, okay, it will be somewhere here, right? At this point. Okay, so it will lie on this axis of symmetry, which means that x bar equals to 0. Okay, so just again, if you see that whatever is the location of the centroid, but x bar will be 0 because it will lie on this axis of symmetry, which is a vertical axis of symmetry. Okay, so that's what we say here in our step 2, that as the area is symmetric, so x bar equals to 0. So I hope you understand why we got x bar equals to 0. Okay, so after we are done with this x bar equals to 0, then we can go and find y bar. Okay, so we know we need to apply the same equation which we used in the previous problem. Y bar equals integral of y bar of the particle times dA divided by integral of dA. Just put in the values. We know what is y bar, right? Y bar is this guy, right? And what is dA? dA is this guy. In the denominator, we only have dA, so dA is this guy. Now, what are the limits? If you come back here, limits are -2 to +2, right? Along the x-axis. Okay, so okay, here are the limits. So the limits of the integral will be -2 meters to +2 meters, right? Okay, so now just simplify these values and apply the integral. So if you simplify the top one, you get this, and the bottom one, it's already simplified. All right, so after this, just apply the integrals in the next step. So here we are, we apply the integrals, we get x by 2 minus x cubed by 12 plus x to the 5 by 160. And in the denominator, we have x minus x cubed by 12. All right, and with the limits of -2 to +2. Okay, so now just apply the limits, you get this. After applying the limits in the denominator, you get this. Okay, so now if you just simplify this, you get this, and you get 0.399 meters as the value of y bar. So y bar equals 0.399 meters, or if you just round it up, you get 0.4 meters. Okay, now again, if you come back and if you see that this guy, let's say 0.4 meters, okay, this guy is 0.4 meters. All right, so sounds right. Okay, so it sounds right. and looks like to be the centroid of the area. So again, if you get a centroid, let's say somewhere here, it cannot be correct, right? So you need to visualize the area and the centroid concept. That centroid is the geometric center of the body or of the object. Okay, and that's how we apply these equations, and we apply these concepts, and we find out the coordinates of the centroid of the area, right? Okay, so with this, we come to the end of today's lecture, and see you in the next lecture. Thank you.